Right, in this video I'm going to run through SC25, which is qualitative analysis, and it's one of only two triple topics that are actually highlighted for paper 2, so it is, according to the advanced information, it is going to be worth a big chunk of marks, and it's also potentially where your 6 marker is going to come from. I know it's not the most popular topic, but it is content that you can just learn off by heart. The questions tend to be pretty standard, so if you've learned it, it should be okay. And what this topic basically deals with is quick and easy tests that you can do in the lab to identify positive ions and negative ions. So if you had a sample and you didn't know what was in it, you could do some quick tests to figure out if you've got a positive ion in there and what positive ion you've got, and quick tests to figure out if you've got a negative ion and what negative ion that might be. So I'm going to focus on the positive ions first. There are two different ways that you can figure out what positive ion you have present, and it depends on the state of your unknown compound. So if it's in a solid state, to figure out what positive ion you've got, you are going to do a flame test. And the flame tests are pretty straightforward. They're all outlined in the booklet, but what you'll need to learn is the ion that gives the particular color change. So if they ask you a question and they say that you've carried out a flame test and you see a lilac flame, they'll say, well, what caused that lilac flame? And you'll say the K+ ion. You have to include the charge on the ion. Just saying potassium is not going to get you the mark. Underneath here, I've also described exactly how you would do the test. You do it on a clean wire loop. It came up before in the mock. They asked you why you dipped it in acid beforehand, and they allowed you to say because it sterilized the wire loop. The other thing you can say is that it causes the solids to stick to the wire loop, and then you can place it in the flame and the colour will tell you which metal ion you've got present. So just make sure that you learn that table off by heart. The other thing you can do is if your sample is in solution, instead of as a solid, instead of doing a flame test, you're going to add sodium hydroxide solution instead. And once you add your sodium hydroxide, so I've got an example here. So let's say, for example, your unknown solution is copper sulfate. So it's in solution. That's why I'm not going to be doing a flame test. I add my sodium hydroxide, and what will happen is the copper hydroxide will form. So the copper from the copper sulfate will react with the hydroxide from the sodium hydroxide. And copper hydroxide is insoluble, and you'll see a precipitate. And in the case of copper hydroxide gives me a blue precipitate. So the color of the precipitate tells me which metal ion is present. So again, you will need to know this table. You'll need to know the charges on the ions, and you'll need to know the precipitate color that you will get. Pay attention as well to aluminium and calcium. They both give you a white precipitate, but I've included here how you would distinguish between aluminium and calcium. It just involves adding more sodium hydroxide. And the other positive ion that you can be asked about is ammonium. So all of the rest of the tests were about identifying metals. With the ammonium ion, NH4+, even though it's not a metal, it is a positively charged ion. And to, I'm not going to write it all out again, but to do the test for the ammonium ion, this is what you'll do. You'll add sodium hydroxide, you warm up the mixture, and then ammonia gas is given off. You need to prove that it was definitely ammonia gas that's given off. So yes, it has a characteristic sharp smell, but to prove for sure that you're getting ammonia, you're going to use damp red litmus paper, which will turn blue. So it does have to be damp, the litmus paper, in order to work. So do make sure you mention that. It's starting off red and it's turning blue. Ammonia is an alkali, okay? That's why it's turning litmus paper blue. And this is the equation for what's actually happening. The ammonium reacts with the hydroxide ion from the sodium hydroxide, and you form ammonia gas and you form water. So you could also be asked for that equation. So they are your positive ions. And then you've got your negative ions, and I've already written this out. So you've got a couple of negative ions that you need to know. The first is the carbonate ion. So to see if you've got a carbonate carbonate ion, you're going to add an acid. Now, technically, you can add any acid, but nitric acid is the best to use, because if you add nitric acid, the only ions you are introducing are the hydrogen ion and the nitrate ion. So if I've got nitric acid, I'm adding H plus ions, and I'm adding NO3 minus ions. And there's no test for a nitrate ion. So using nitric acid doesn't give you false positives later on. I'm going to use nitric acid, and if I see bubbles, then I know I've got a carbonate present. And the reason why is because CO2 is going to be produced. If you've got a carbonate present, that's why you would see bubbles. Another test you need to know is the sulfate test. So the first thing I'm going to do is I'm going to add some nitric acid. And again, I'm doing this to make sure I don't have a carbonate present. Once I see that there's no bubbles, I can rule out carbonate, and then I can continue on with my sulfate test. But if you're asked purely for a sulfate test, you do still need to say that you're going to start by adding an acid. I'm not going to use sulfuric acid, okay? Because if I add sulfuric acid, I'm adding sulfate ions. And then if I do the rest of the test, of course I'm going to get a positive result. I've just added sulfate ions. That's why I'm going to use nitric acid. So I add my nitric acid. If I don't see any bubbles, I can rule out carbonate. I move on to the sulfate test, and I'm adding barium chloride, and what will happen is the barium from the barium chloride reacts with the sulfate if it is present and gives you a white precipitate, and the reason because barium sulfate is insoluble in water, that's why it forms a solid precipitate. The other test you need to know is for halides, so any of the group 7 ions, so chloride, bromide or iodide ions. Again, I'm going to start by adding nitric acid. This is to rule out the presence of a carbonate. I'm not going to use hydrochloric acid here. If I use hydrochloric acid, I'm introducing chloride ions, and then of course I'm going to get a positive test later on, so I'm going to use nitric acid. And once I've ruled out the carbonate, because I see no bubbles, then I'm going to proceed with the halide test. To do the halide test, I add silver nitrate. The silver from the silver nitrate can react with the halide if it's present, and if it's chloride ions are present, I get a white precipitate. Bromide, I get a cream precipitate. Iodide, I get a yellow precipitate, and that's because silver halides are insoluble in water. Now, what they can ask you, I'm just going to do some example questions here, because what they can ask you to do is they can ask you for equations. So let's just say they tell you that you have got aluminium sulfate, and they want you to do tests to prove that you've got aluminium and to prove that you've got the sulfate ion, and they tell you that aluminium sulfate is in solution. So if you've got aluminium sulfate, then the ions from aluminium sulfate are the aluminium ion. Aluminium's in group 3, so it's got a 3+ charge. And you've also got the sulfate ion, SO4 2-. Okay, so they're the 2 ions you've got present in aluminium sulfate. And the first thing you're going to need to do is prove that you've got the aluminium ion. So we said if you're testing for positive ions and it's in solution, you're going to be adding NaOH. So I'm going to be adding NaOH, and what I'm going to see, if I consult my table, for an aluminium ion, when I add NaOH, I should see a white precipitate. So I would say add NaOH. I'm going to get a white precipitate, which I'm going to abbreviate to PPT, but don't do that in your exam. You get a white precipitate, and then according to my table, white could be calcium or it could be aluminium. To prove it's aluminium, I then need to add excess NaOH, and if it's aluminium, I should end up with a colourless solution. So in other words, my precipitate will disappear if I really do have aluminium present. So you'll write that out. But then they might say to you, show an ionic equation for the reaction as well. Okay, so the ion I'm concerned about from aluminium sulfate is the aluminium. So I'm going to include that in my equation, Al3+. And I'm reacting this with sodium hydroxide. So sodium hydroxide contains the sodium ion and it contains the hydroxide ion. Now of those 2 ions, it's the hydroxide that reacts with the aluminium. So I'm going to have Al3+ and the OH-. And if they react together, they're going to give me aluminium hydroxide. This has got a 3+ charge, which means I need 3 hydroxide ions to cancel out the 3 positive charges in aluminium. So that's my formula for hydroxide. This isn't balanced. I'd need to put a big 3 here. And that's going to be my equation. If I was asked for state symbols, when they're ions, they're dissolved in water. But on this side, I'm forming a solid. I'm forming a precipitate, and it's white. So that's me showing that I've definitely got aluminium present. They could then ask you, well, show that sulfate is present. And if they asked you that, you describe this test. You say you add nitric acid, then you add barium chloride, and you're going to see a white precipitate. And again, they could ask you for an ionic equation. So I'm adding barium chloride. Barium chloride contains a barium ion. Barium's in group 2 with a 2+ charge, and the chloride ion, Cl-. So of these two ions, the sulfate is going to react with the barium. Negative will react with positive. So I don't even need to include the chloride ion in my equation. I'm just going to include the barium. And I've got my barium, 2+, and I've got my sulfate, SO4, 2-. 2+, 2-, the charges immediately cancel out, and I get BaSO4. And again, if they ask for state symbols, when they're ions, they're aqueous, they're dissolved in water, but on this side, I have got a solid. I've got a precipitate, and as mentioned above, that precipitate is white. Okay, you can do the same thing again. This time, let's assume that they're asking you to prove that you've got ammonium chloride. Ammonium chloride contains the ions ammonium, NH4+, and chloride, Cl-. So testing for my positive ion, so remember ammonium is the one that you have to learn the test for. To test for your ammonium ion, you're going to be adding NaOH. And they can ask you for, add the NaOH and warm it. And again, they can ask you for the equation for that reaction. So again, NaOH gives you sodium ions and it gives you hydroxide ions. Of these two ions, it's the hydroxide, the negative, that will react with the positive ammonium ions. It's going to be NH4+ and OH-. The sodium is not going to be involved in the reaction. I don't even need to include it. It's what we call a spectator ion. And when these two react, what's going to happen is the OH- pulls one hydrogen away from the ammonia to give you H2O, and then you're just left with NH3. And again, this is aqueous, water is a liquid, and ammonia is a gas. And this gas, ammonia, you'll be able to smell it. It's quite a characteristic smell. But to prove that you've definitely got ammonia, then you would use your damp red litmus paper, and that would turn blue. And again, it's turning blue because ammonia is an alkali. So that would be the equation associated with that reaction. And then they ask you to confirm that you've definitely got your Cl-. So if I'm confirming I've got Cl-, I'm adding silver nitrate. So again, doing this one, the first thing I would say is add in nitric acid. You don't have any bubbles, so you know you don't have a carbonate. So once you've done that, you're going to add your silver nitrate. And if we look at the silver nitrate, the ions you've got present are Ag+ and NO3-. So of these two ions, which is going to react with the chloride? It's going to be the silver. And it's going to be Ag+ plus Cl- goes to AgCl. Plus and minus immediately cancel out. So that's aqueous, and then on the other side you're forming a solid. So you're going to see a precipitate, and because a precipitate includes chloride ions, it's going to be white. If it was bromide, you'd have exactly the same equation, but you'd be getting a cream precipitate. Iodide, the same equation, but you'd be getting a yellow precipitate. If we just do... Oh God, we'll just do one more. Let's say, for example, they give you, let me think. Right, let's say they give you lithium sulfate. And this time they tell you that your lithium sulfate is solid. You've got lithium Li+, it's in group 1, and sulfate ion SO4 2-. So because you've got a solid, how are you going to identify that you've got your positive ion? You are going to use a flame test. And because you've got the lithium ion, you are going to see a red color. Okay, so that's all you would need to say for how you'd identify your positive ion. And there is no equation needed when you're doing the flame test. And then you've got your sulfate ion. Okay, so when we're doing these tests on the negative ions, it has to be in solution. So I'd first say that you have to take your lithium sulfate and dissolve it in solution. And once you've got it dissolved in solution, then you're going to be adding your barium chloride. And again, if they asked you for an ionic equation for that reaction, it would be exactly the same as the one we wrote before. It would be the barium reacting with the sulfate to form barium sulfate, but you would need to dissolve your solid in solution before you carried out that test. I mean, that is it in a nutshell. You just need to know all of your colors, all of your tests, all of the charges on all of your ions. Like, you need to know the charge on all of you need to know the formula of all of your polyatomic ions. And then you need to be able to write these ionic equations. But they're all essentially the same. So if I were to write another one here, doing the sodium hydroxide test, if I had iron, Fe2 plus, and OH minus instead, I've got 2 positive charges on iron, so I need 2 hydroxides to cancel it out, and then I go back and I balance it. All of those ionic equations are going to be exactly the same, but just make sure you are familiar with them, because you could be asked. I mean, beyond that, the only other thing I want to point out is, if you look here at the method, I know we never actually did this core practical, but if you look at the method, again, you'll see here, testing for halide ions, testing for sulfate ions, you're always adding in some acid before you do the test. Do make sure you include that. The mark scheme looks for it. And also have a look over instrumental analysis. Again, it's just a little bit you have to learn in terms of why a photometer would be used, and the kind of benefits of using a photometer over just doing a flame test, and then just being able to use a calibration curve to work out what the concentration of your ion would be.